In this video, we're going to review sequences and series. A sequence is a list of numbers with a special pattern or in a special order with a pattern of addition or multiplication. So I know I'm either adding something as I go from term to term, or I am multiplying something as I go from term to term, depending on what kind of sequence I have. A series is the sum of the terms of a sequence. So if I sum that list of numbers or part of that list of numbers. A sequence which generates its next term using addition is an arithmetic sequence. So when I see addition is the pattern, I know it's arithmetic. And the formula for that is a sub n is equal to a sub 0 plus d times n. A sub 0 is the term before the first term. D is the common difference. A sequence which generates its next term using multiplication is a geometric sequence. So if the pattern is multiplication, I have a geometric sequence. The explicit formula for that is a sub n is equal to a sub 1 times r to the n minus 1 power, where a sub 1 is the first term and r is the common ratio. A sub n for both of these explicit formulas represents what the actual term is. N represents the position. So a sub n is equal to the term, and n is equal to the position. Here I have a sub 0, term before the first term, and d is the common difference. The added things that I have in this next explicit formula is a sub 1 is the first term, and r is the common ratio. All right, the sum of the first n terms of a sequence is called a partial sum. So it's a partial sum, and we denote it by s sub n. To determine if a geometric series converges, we check to see if r, the absolute value of r, is less than 1. Because if r is less than 1, it converges. The equation for the partial sum of a arithmetic series is s sub n is equal to n over 2 times a sub 1 plus a sub n. This is the, so for an arithmetic series, a partial sum, this is the formula. A partial sum is for finite. So partial sum is another way to say finite. Right? Finite number of terms added together. So finite arithmetic is that formula. The equation for the partial sum of a geometric series is s sub n is equal to a sub 1 times 1 minus r to the nth power all over 1 minus r. So this is the formula I use when I have a finite geometric series. So another way of saying partial sum, or what partial sum means, is I have a finite number of terms being added together. And then the equation for an infinite sum of a geometric series is s is equal to a sub 1 over 1 minus r, and I can only use that if the absolute value of r is less than 1. Otherwise, I have no sum because the series converges. So this is for an infinite geometric series, the formula. So those are the 3 formulas you need to know for sum. These are the 2 formulas that you need to know for the sequences. For this next part, I'm going to determine the explicit formula for this list of numbers. First thing I want to do is find what's the pattern and then decide is it arithmetic or geometric. Well, as I go from 4 to 11, 11 to 18, 18 to 25, the pattern is I'm adding 7. I'm adding 7 each time, which means this is arithmetic. So this is arithmetic. And I know that I have then a common difference, and that common difference is 7. I want to find the first term. I actually want to find the term before the first term. So the first term I know is given to me, it's 4. And to go backwards from that to find a sub 0, so this is a sub 1, a sub 2, a sub 3, a sub 4. I want to find a sub 0. And a sub 0, I know I would subtract 7, go backwards from 4. And that would give me -3. So a sub 0 is -3. I'm subtracting 7 from 4, which gives me a sub 0 is -3. And then I use that information to complete my explicit formula. -3 plus 7n is my explicit formula. For the second list of numbers, I want to determine the pattern as I go from term to term. I'm multiplying by 3 each time, which means this is geometric. So it's geometric. I know I have then a common ratio, and the common ratio here is 3. The first term, now I do want to use the first term since it's geometric. The first term is equal to 4. And so my explicit formula is 4 times 3 raised to the n minus 1 power. I want to identify if the following are arithmetic, geometric, or neither. For this first example, I know as I go from term to term, I do not see a pattern, so this is neither. I'm adding 3, then I'm adding 2, then I'm adding 5, so neither. For this next one, I see the pattern as I go from term to term is I am adding -3 or subtracting 3 each time. So subtracting 3 each time, which is adding a negative. This is then arithmetic, since it's addition, technically. For the next one, as I go from term to term, I'm multiplying by 10. So this is geometric, since multiplication is the pattern. And then for the last one, as I go from term to term, I'm adding 5. If I'm adding, the pattern is arithmetic.